I was a planning manager at Atlantic Richfield at ARCO, and I was an independent oil and gas producer and involved and owned onshore and offshore oil rigs for about 20 years. The first time I became aware of horizontal hydrofracking was in the San Juan Basin in Colorado. We had a property across the state line at New Mexico, and operators were starting to frack coal bed, coal seams horizontally. In other words, they drill down into the coal seam, put a frack on it, and release the gas out of the coal seam. That started maybe 20, 25 years ago. That technology has evolved, frankly, through some DOE grants and a lot of research, into fracking increasingly hard rock formations that are monolithic in a shelf form. And so that the technology is not new, but what happened is, since the density of the material that's being fracked, the porosity, the permeability of it is so low that the pressures necessary to break that rock up have gotten extraordinary. The industry will say anywhere from 8 to 10,000 psi. There's anecdotal data that it goes all the way up to 15,000 psi. So if you put that much pressure, and that's significantly more than the pressure that they started out with fracking coal bed, that kind of pressure, if say 15,000 psi, is about the pressure at 6 miles below the surface of the ocean, as say in the Marianas Trench. It's about approximately 30 times the pressure of an air bomb, of a thermobaric bomb that they would use in Afghanistan or in Iraq. So when you're dealing with the amount of fluid involved, anywhere from 1 million gallons to as many as 3 million gallons, you're dealing with that kind of pressure. What effectively you're doing is you're exploding a bomb underneath the ground. It's a horizontal bomb, it's a pipe bomb, but the explosive power of it to break that rock up is equivalent to a really large bomb. And the problem there, and this is particularly applicable to this area, to New York, is that you're going through what's likely to be inclined and vertical faulting. In other words, natural occurring fracturing of the earth subsurface, some of which can go from the bedrock all the way up to the surface, some of which in the New York area is actually seismically active, meaning occasionally you'll get an earthquake here. There's not a lot of seismic data in this part of New York, and the odds are is that you will hit a fault that you can't see from the surface. When you frack the fault, what would happen is that you'd open that fault line up. The propant out of the fracking fluid would prop that fault line open, and that fracking fluid would go right up through that fault. It would go up into an aquifer. It ostensibly could go all the way to the surface. But you've basically blown open a piece of the earth. You've propped it open with a proppant. You've released fracking fluid and you've released natural gas into it. And that's how this particular type of hydrofracking, and hydrofracking's been around for years, horizontal fracking's been around for years, but this particular type of hydrofracking in this particular environment could introduce fracking fluid, some of which is toxic, all of which is non-potable, and natural gas into aquifers. When it gets into the aquifer, it's going to get into somebody's water well, it's going to go out through a spring, it's going to communicate with other strata, some of which will communicate to the bottom side of that lake out there. It's going to get into the drinking water. When that fracking fluid gets into the drinking water, you can't get it out. You can't get it out of the aquifer.